Hello, my name is Kamlesh, and today's topic of discussion is K-curve methodology. In this K-curve methodology, it's being used in the inventory management. Basically, in the warehouses, a large number of parts are to be handled in very less number of time. So we have various inventory management techniques, like we have the EOQ model, stands for economic order quantity, ABC analysis, Pareto analysis, and the K-curve methodology. Okay, and this EOQ and ABC analysis, or you can say the Pareto analysis, can be are being used from a long time as the one of the most cited tools in the inventory management. So we will be discussing about these first. So let's start our discussion about EOQ model. So EOQ stands for, I told you, that economic order quantity, and it is basically gives us the optimal quantity to order the inventory. uh, okay, and the goal is to have a balance between the two factors. See, for any inventory or for any warehouse, there are two costs which are most important, uh, and must be take care about the most, like the ordering cost and the holding cost. So these two costs are to be balanced, and then we have to make a decision to order the quantity of the items. So if you see the graph here, this x-axis it has the order quantity, and y-axis have the annual cost. So, and this straight line starting from origin is called as the carrying cost. Okay, and this is called as ordering cost. So ordering cost, this is carrying cost. And so if you see, as the ordering quantity increases, if you see on the x-axis, as the ordering quantity increases, the carrying cost also increases. So these two are directly proportional. But whereas the ordering cost and the order quantity, these two are inversely proportional. So as the ordering quantity increases, your ordering cost decreases. Okay, so similarly, we have the formula for EOQ, that is EOQ is equal to root over 2D C naught by CH. C naught is nothing but the cost per order, and CH is nothing but the holding cost, and D is the demand. So we are also having some other formulas like average inventory Q by 2, expected number of orders N is equal to D by Q star, where Q star is the EOQ. Okay, and expected time between the orders is equal to Q star by D. So the total cost is equal to carrying cost plus ordering cost. This ordering cost is also called as, the carrying cost is also called as holding cost. Okay, so this is the formula for total costs. Next, we'll be discussing like what is EOQ. EOQ is nothing but it is the optimum quantity for an order or for an item that should be ordered at a particular point of time. Okay, see, the main advantage of this EOQ is that it always avoids overspending of an item to minimize the ordering and holding costs. Okay, so this EOQ consists of two parts, ordering cost and holding cost. Ordering cost is nothing but cost incurred at the time of placing each order, and holding cost is the cost incurred to hold and carry the inventory. Okay, so this is the formula for the EOQ. Okay, and this is a small example for better understanding of the EOQ. Okay, so the importance of the EOQ is that it always tries to minimize the wastage and stockouts, but whereas it's mostly used in case of multiple products. Okay, so this EOQ also have some limitations, like it assumes that always the demand is constant throughout the year, but it is not the case in the practical application or in the real life. Okay, similarly, the EOQ also assumes that inventory will be restocked in each time. Okay, inventory will be restocked in the each time. There are some more limitations of this EOQ, like it assumes that the ordering cost and the carrying cost both are constant. Okay, and lead time is also constant. So uh, but when I talk about the actual practice, it's never going to be constant, like your ordering cost, your carrying cost, and your lead time are never constant in the actual practice. Okay, so that is the main limitations of the EOQ model. So it cannot be used in some circumstances. Okay, next one is Pareto analysis. This Pareto analysis is basically using the Pareto principle which is also called as the 80/20 rule, and it was invented by a Italian economist called as Pareto. Okay, and it is basically a decision making tool which is similar to the ABC analysis. Okay, and it also has some limitations, like it assumes that the grouping is based on the annual demand, but the demand is never constant, it also varies. Okay, and basically this Pareto and EOQ are simple and most effective, and they are being used by the warehouses from long times, but they give the misleading results which can have a drastic impact on the warehouse. Okay, so some better methods are required, like a K-curve method. Okay, so now we'll be discussing about the K-curve method. So K-curve method is nothing but a combination of strengths which are taken from the EOQ as well as the Pareto analysis. Okay, so this K-curve is algorithm is applied to data and range of K values. So this is basically a tested method. Okay, and it is tested for various K values. Okay, and this we will be getting the optimum inventory value. We will be getting the optimum inventory value. And when we are generating a K-curve method, we'll be taking an example where the K value is 30, and we'll be assuming the number of working days from around 250, and we will be doing this analysis for 200 parts. And basically this K value is varying from 1 to 100, and this K is nothing but a constant, and a K is equal to 2C by I. Okay, so basically to generate a K curve, we have to go through 3 stages. Like stage 1 is you are expressing EOQ as an economic period. Okay, and stage 2 is nothing but you're building a bridge between Pareto and EOP, like your economic order period. And stage 3 is variation of K to create a exchange curve. So these are the 3 stages: stage 1, stage 2, and stage 3. Okay, so before going into the stages, let's discuss some formulas, like uh, A is the annual demand, K is constant. We can assume any value from 1 to 30, but here we have taken the value of 30, and W is the working days, and the most commonly used the working days is 250, as we have to remove the holidays and everything from the 365 days in a year. So generally we consider the standard value of working days is 250, and EOP is nothing but the economic order period, which is nothing but W times root over K by A. W is the working day, as I told you, and K is the constant, and A is the annual demand. So if you put the values of W, into K root of K by A, the above values, then you will be getting the value as 5 days. So for example, W is 250 into root over value of K is 30, so 30 by A. What is the value of A? 75,000. So 30 by 75,000. So if you do this calculation using a calculator, we'll be getting the value as 5 days. So this is your economic order period. Okay, so first we need to change the formula to give the annual spend to, for a given value of EOP. So annual demand is A1. Annual means for a given financial year or for a given year. Let's say annual demand is A1, and for some another for some another year, let it be say A2. Okay, so the formula for A1 is equal to W square into K by E1 square, and A2 is equal to W square by K into E2 square. Okay, so similarly, if you put the values of W, K, E1, then we will be getting the value as 250 into 250 into 30 by 5 into 5, as W square means 250 into 250. So that is the reason why we have got 250s. 250s, okay, into K value is 30, so into 30 by E1 square, so 5 into 5. So okay, so this is the calculation part, and if you solve this one, you'll be getting the value as 75,000. Okay, similarly, the value of A2 is 18,750. The steps are similar to the A1. Okay, so this is how we will be getting the value of A1 as 75,000 and A2 as 18,750. Okay, so next what we will do is we will first find a class limit Okay, so to find a class limit, we cannot take the average value of a1 and a2 as the k curve is not straight line, it is a logarithmic curve. So we have to take the log function to find out the midpoint of the a1 and a2. So if you want to get the midpoint, so midpoint demand is equal to log am is equal, so log am and am is midpoint, so log midpoint of a is equal to log a1 plus log a2 by 2. So this is a simple algebra by putting the values of a1 and a2 here. So a1 is equal to w square into k by e1 square, which can be seen above. So a1 is equal to w square into k by e1 square. So I have put w square into k by e1 square in place of a1. Similarly, we have to take the value of a2. So upon simplification, we will be getting the value is equal to log w square into k by e1 into e2. So by applying anti-log on both sides, we will be getting am is equal to w square by k by e1 into e2. So this is the formula, final formula. Okay, so on simplification, we'll be getting 250 into 250 into 30 by 5 into 10. So on calculation, we'll be getting 37,500. This calculation is important. We will be reviewing this calculation again when we go with the excels. So please remember this one. Okay, so this is about midpoint demand. This is about the midpoint demand. So we are having some more formulas, like let us assume that the demand is 1000 this time. Cost per ordering is $4, I mean 4.5 euros, and P is the unit cost 75 euros, and I is the inventory holding rate 30%. Okay, so EOQ is equal to root over 2DC by P into I. Okay, so where Q is equal to, so if you put the above mentioned values in this formula, we'll be getting the value as 20. So D is nothing but your 1000. So 1000. C is nothing but ordering cost, or you can say cost of ordering 4.5. So 4.50. Okay, by P values unit cost, so 75 into I is 30%. So 30%. So on solving, we'll be getting the value as 20. Similarly, the K common factor K is equal is 2C by I. Okay, so 2 into C, what is the value of C? 4.5 by 30%. So on solving, we will be getting the value as 30%. So EOQ is equal to root over K into D by P. So on substituting the values and solving, we will be getting the value as 20. So EOP, economic order period, is equal to economic order quantity by demand. So economic order quantity, we have just gone now, we got the value of EOQ. So 20 by demand is 1000. So 20 by 1000 is equal to 0.02 years. So if you want to convert this years into days, then we know that 250 days is equal to 5 days. No. Okay. So we have to convert this years into days. So for that one, we can use this formula. Okay. So the answer is 5 days. Okay. So economic order period can be also defined as W into root over K by A. W into root over K by A, where W is the number of working days. So 250 into root over K. K is 30 by annual demand. What is the value of annual demand? So annual demand. Okay, we will be discussing further. So by putting all these values, we will be getting the value of EOP. Okay, we will be getting the value of EOP. Okay, so I think you understand my point. See, this constant K is nothing but we can simply obtain by using this formula. I will show you. 1 second. Okay, so 2 CD by K. So 1 second. Oh, where it is? Sorry. So 2C by I, you can see here, we can replace it by K. 2CD by I, we can replace it by K. You can see it here. So in this formula, we can replace it by K. So basically this is taken from the EOQ model formula. Okay, basically it is taken from that formula, and if you do that formula, we can get the value of K, and this K value will be changing with an interval of 10. Like we will be taking 5, 10, 20. I will be showing you in the Excel graph in the upcoming slides, so that you can have a better understanding of the graph. See, basically now I will be providing you an Excel sheet which is having 200 parts, and in these 200 parts uh, everything will be given. Like the only thing is you have to vary the k value. The working days are fixed 250. Okay, and then we have to uh, we have to just calculate the EOQ model, and then we have to calculate the EOP model, like we have to calculate EOQ, EOP, and then we have to calculate the value class. Okay, so like average inventory, average cost, so all this we have to calculate, and then we'll obtain a curve. So I will be just showing the same in depth how we can do this stuff by using an Excel sheet. Okay, it's nothing but formulas, but so if you know well Excel, I mean if you know how to use the Excel well using the formulas, is very easy. So let's begin the formulas so that you can have an idea. And um, yeah, so let's begin with the Excel sheet now, so that it's very easy to do the calculation part. But these formulas are very important. You have to go through these formulas, and then you can start the actual Excel sheet. Okay, um, it's nothing but some just a matter of formulas, like we have to use the Excel. Okay, so let's start the begin the actual thing. Okay, so you can see the parts which I have shown here. Around 200 parts will be, you can see here. This is 1 2 till 200 parts, and this is the uh, part name, and this is the annual demand. Okay, and this is the cost per price, I mean cost per each part. This is the annual spend. Okay, that means annual demand, I mean annual spend value of the company, of the warehouse. Now the first step is to calculate the EOQ, and to calculate the EOQ I told various formulas in the presentation slide. If you remember, we have to use the same formulas. Okay, so the same formulas which can be used here, so is equal to square root of root over b1 means is nothing but it is the value, the k value. So here we have assumed the k value is 30. Okay, and similarly into C18. C18 means it's the annual demand, so it is nothing but k into annual demand by the cost per price. So the square root of that formula will be giving you the EOQ value. So you have to do the calculate. So you have to put the formula for EOQ in the first count. I mean in the first part, first cell. Okay, and then you have to drag it to the other cells. But remember that when you are doing this, when you're doing this or dragging this cell to the other cells, you have to freeze the B1. Okay, so that the Excel won't take the any garbage values like B2, B3, B4. We have to fix the value of B1, as in this case we have taken a k value as 30 only. Okay, so next what we will do is we will calculate the EOP days. So to calculate the EOP days, it is nothing but EOP days is equal to EOQ by the annual spend. EOQ by annual spend. So that is the formula for EOP. The same formula you can see here in the at this place. You can see here I highlighted for you. So it is nothing but 250, I mean working days into square root of k by annual spend. Okay, that is the formula of EOP in the days. Okay, so this is how you will be getting the value of EOP, and in this case also you have to do only for the first cell, and for remaining all cells you have to just drag this to till last part. Okay, and make sure that when you're dragging always the k values, or specifically here we are having the k value and working days, both are constants, so you have to freeze the working days as well as the k value. Okay, so this is about the EOP days. This is about the EOP days. Next, the important thing is the value class. So this value class, nothing but what we will do is we have divided the parts into various classes. Okay, so here you can see here class 1, class 2, class 3, 4, 5, 6, 7, 8, 9. So we are taking these classes. Okay, and next we have to take the cycle days 5, 10, 15, 20 till 160. We are taking the cycle days. This is the class limit. So this 37,500, it can be calculated by using the formula which I have shown you previous. What is the formula? If you remember, the formula to calculate the uh, class limit is nothing but w square into k by e1 into e2. That is the formula for the class limit. So if you put the values and you solve, we'll be getting the value 37,500. But actually, if you remember, I have already done the same in the previous one. The same I have shown the calculation already. So if you have any doubt, you can please have a look. Okay, so this is how you will be getting the value of how you will be getting the value of uh, class limit. Similarly, you have to get the value of class limit for all the others by dragging the first cell. Okay, so this is about how we get this table of value class, cycle days, and class limit. Similarly, if you want to get the value of value class, means which product is comes under which class, you have to differentiate or we have to divide into groups. Okay, so to get that one, we have to use this formula. It looks a bit lengthy, but it's very easy to understand. It's nothing but simple algebra. Okay, so if you use this formula, we'll be getting this value class directly. Okay, so till now you drag till the last end, so that you can get the value of, I mean, so that we can divide all the products into various classes. Okay, so if you see here 7, 6, 1, 1, so the number of 7 means the part number AB 001, I mean AB 00001 is coming under class 7, which means it is the class number 7. Okay, if you take the products 3 and 4, count number 3 and 4, it is coming under the class 1. It's coming under the class 1. So this is how we just give the value class, just nothing but the grouping. Next one is cycle days. So cycle days is nothing but you have to choose. So this is the formula for cycle days. How we have to choose the means to determine the cycle days, means after how many days you have to place an order for a particular class of items. So if you see here, for class number 7, you have to place an order after 160 days, means each 160 days you have to place an order. For class 7, for value class 7, we have to place an order after each 160 days. Okay, similarly for class number 1, you have to place an order after each 5 days. So every 5 days you have to place an order for the goods coming under the value class 1. Okay, so this is the meaning of the word cycle days, and this can be obtained by the formula which is mentioned here. Okay, next one is number of orders. Like how many orders you have to place. Okay, and it can be obtained simply by dividing the working days by your cycle days. It can be obtained by dividing the working days by your cycle days. So if you use that formula, we will be getting the number of orders value, and you have to drag it till 200 parts. Okay, so this is how you will be doing the number of parts. So next one is the average inventory. So average inventory is the formula for average inventory is 0.5 into your cycle days into your annual demand by working days into your cost per price. So this is the formula for the average inventory. So you have to use this formula, and then you have to drag it to the last part so that we can get the average inventory value for all the given parts. But in this one, remember that you have to always freeze the constant and working days both, not only in the average inventory but for all the formulas. Wherever you are having the value of k and wherever you are having the value of working days in the formula, you have to freeze them so that uh, for all the parts the same value of k and same value of working days are taken. So this is the thing where you must take the utmost care when doing the calculation part. Okay, so now what we will do is like this you can vary the value of k from 1 to 100. So if you see here this slide, the value of k is 1, the value of working days is 250. So the remaining all things will remain same. Okay, only the value of k will change. So again you see here the value of k is 5, working days will remain 250 only. For each and every k value the working days will remain same. So this is what you will do for all the k values. So now you take k value 10, you see here you take the k value 10 here, and okay, working days will be 250. So similarly for k20, the k value 20 you have to take k is equal to 20, and for k value 30 you have to take k value as 30. So similarly you have to do for 80, 90, 100, for all the things, for all the tables you have to take the k values varying for each table. Okay, and after doing this one, what you have to do is you have to just take the average value of number of orders and the average inventory. You see here, this is the average value, this is the average value of average inventory, and this is the average value of number of orders. You see here, this is the average value of number of orders, this is the average value of number of orders. So now for all the values of k, the average value of number of orders and average value of number of inventory should be taken in this table. So you see here, this is the number of orders, average value of all the orders and average value of inventory, and you have to plot a graph between the average inventory and number of orders. So you can see this is the graph how we will be obtaining. Okay, so the most important thing is that as the number of orders decreases, the average inventory increases. So these two are inversely proportional, these two are inversely proportional. Okay, and here are the k values. K value ranges from 1 to 1, 5, 10 till 100. So this is how we will be obtaining the value of k, and this is the graph. So now we will learn how to plot the graph between the average inventory and the number of orders. So first of all, what you will do is just select the number of orders and average inventory from B3 to C15, and then go to insert. Okay, and then go to insert, and there you can see one insert line or chart area. Click on that, and then you please select the scatter point. Please select the scatter point. Please be careful as you should not select the lines one. The things will remain same, but the only thing is that you will change the presentation. But it's better to select, like go to more line charts, and then you go to this XY scatter. Okay, and then choose this one. Okay, and then click OK, and then you select, means if you can change also this one. Okay, so this is how you will change the design type. Further, if you want to add a line, you can just have this one. Okay, so this is how you will create the chart, finally the required chart. And you have to add the axis, like go to plus, select axis titles, and then just write here average inventory, on the y-axis, and on the x-axis write the number of orders, Okay, so this is how you will be providing the access to this thing. Okay, so this is about how to plot the how to obtain a k curve by using various k values. Thank you so much.